So good morning everyone. So first we'll take computer organization class. After that we'll take digital communication class. Okay. Uh, we'll start by 1 minute. So today's topic is last day we have done all the operations, that means addition, okay, increment, jump, branch instructions, all these things. Today we are going to discuss about input, output and interrupt. Input output operation, because when you are having on computer there should have some sort of input devices and the output devices. They are communicating with the computer, that means with the processor, and as you know input devices are slower than the processor. So how they are interacting with the processor, okay, means the input output devices, how they are interconnected and how they are sending the data, okay, to the processor, and okay, so that we will be discussing here. So you are having some arithmetic logic unit, so the data is coming to the arithmetic logic unit and some processing is there. After processed data, that must be come out to the output device. Okay, so some mechanisms are there, some timing signals are there, you have to know about that. And the last thing is that the interrupt, as you know interrupt means some intervention. You are having some normal operations, and if there is some sort of breakup, so that means interruption occurs. So I can give you one example here. Okay, so simple example for interrupts. You who also studied this interrupt in 8085 microprocessor, so many interrupts are there. So basic thing is same, nothing more than that. So whenever suppose a simple example means a class is running, teacher teaching you, giving some lectures to the students. Okay, it's a normal process. Is normal execution is running. In the meantime, somehow principal has come and she or he knocks the door. So and you open the door and you observe principal has come to visit the class. Then what will you do? You have to stop the normal execution, means the class. Okay, the lectures. You will stop there, and you will be busy with some other activity with the principal ma'am. What he or she actually want to say. So there is some sort of conversation. So that is one sort of interrupt. Okay, you are doing some normal operation, somehow that is having some problem, it's some having some obstacle, then there is called the interrupt. So this is simply one example of the interrupt. So that will be discussing here, but here we will not going the detail of the interrupt classification everything, because for that we are having another topic in another chapter. The concept, how the control signals are there for controlling interrupt, what is their role and the functions, that much. Okay, so come to input output configuration. Okay, so this is the simple diagram. Okay, input output configuration. So as you know, the basic example of input device is keyboard, alphanumeric. You can have the input here. Okay, and there is a transmitter interface, and there is input register. This is important. The input register is there. That means the data which is coming from the keyboard or the outward through this serial communication interface. to the input registers. Okay, and then from this input register, data will be moving to the accumulator. So there is a serial communication from input register to the accumulator. There is a serial communication between keyboard to the input register. Now at the output side, there is having a one more register that is called output register. You have heard the name. These are basically for 8 bits register. You know that when we have discussed about the registers, there is, and I told about their names. So from accumulator to output register, there is a parallel communication. So the data or the processed data or the result that will be moving to the output register, and that will be to the, it may be the printer through this receiver interface. But among these blocks, you are having two more blocks. That is FGI and FGO. These are the flag. Okay, these are the flags. So input flag and this is the output flag. So flag means either it should be 0 or 1, any one. Either it should be 0 or 1, FGI should be 0, FGI is equal to should be 0 or 1. Similarly, FGO should be either 0 or 1. When it should be set and when it should be reset. Similarly, when FGO would be set and reset, that is depend upon the operations. Okay. Now, this is having three layers. The first one is input output terminal. This is the first one. The middle one is interface between the input register, output register, and the output device, the input device. So this is serial communication interface. So serial communication taking place here. And this is your computer register and the flip flops. So these are computer registers, INPR, OutPR. Okay, accumulator is the kind of registers, and these are the flags. So flip flops actually. So because it contains single bit, either 0 or 1. So this set and reset. Okay, this is uh, uh, these are basically a 1 bit flip flop. Okay, so these are the flag registers actually. Okay, or flag flip flop, whatever you can say. It should be either set, reset, reset. Now, this is the case. So now the data, alphanumeric data will come from the keyboard to the INPR. Okay. When the data, if it is FGI is 0, listen carefully. If when FGI is equal to 0, then what will happen? You can enter some data. Okay. You can press keyboard. Then that data means that alphanumeric data will come to the INPR, input register. Okay. So when this FGI is 0, that means the data which you are entering this in this keyboard, that will move to the register, input register. Clear? So after that, what will happen? This data will move to the accumulator. Okay. The data will move to the accumulator. When this communication will take place from input register to the accumulator, at that time FGI should be high. If FGI is low, no data communication from this INPR and the accumulator. In that time, communication is taking place between keyboard and that means the input device and the input register. When the FGI is equal to 0. So until and unless FGI is equal to 1, no data communication taking place between these two. So when FGI is equal to 1, at that time, data are moving from input register to the accumulator. During that period, the keyboard will never take the data as input to the INPR when FGI is equal to 1. So every time computer will check this flag register. Okay, flag register, whether it is 0 or 1. If this flag register is 0, then will have the chances to receive the data from the input device. If this is 1, that means the flag register in is FGI is equal to 1. That means computer will assume that the data communication taking place between the accumulator and the input register. So at that time, keyboard never send the data to the INPR. This is all about here, the communication here. Now in this side also, when FGO is 1, when FGO is 1, then the data communication taking place between accumulator and the output register. And the similar way. But here the direction of the data and here the flow of the data is completely opposite. Here outside world to the accumulator, here accumulator to the outside. So the completely reverse operation is taking place here. So you people listen carefully and you will be understand all the things. So you will understand all the things. So accumulator sends the data to the output register parallelly when FGO is equal to 1. So that means either FGO or FGI when 1, that means communication taking place between the input register to the accumulator or accumulator to the output register. When FGO is equal to 1, at that time data communication taking place between the accumulator to the output register. When FGI is equal to 1, at that time data communication taking place between input register to the accumulator. This is the aim to say. Now, when this data which is coming from the accumulator, which is stored at output register, so that data will move to the printer through the receiver interface, and that time FGO should be 0. Listen carefully. Then that time FGO should be 0. So until and unless FGO is equal to 0, no data can be transferred from the output to the printer. And when this FGO is equal to 0, okay, then that time no data has been transferred to the accumulator to the output register. Computer will assume that the printer is engaged and that is printing the data which is coming from the computer. So that time you can't send the data from accumulator to the output register when FGO is equal to 0. When FGO is equal to 0 means the data is moving from output register to the printer. So that I mentioned you. Okay, input output configuration. If you have any doubt, you can tell me, I can explain it. Okay, so data are moving from keyboard to the accumulator. Okay, and that time FGI, the primarily, okay, when FGI is equal to 0, then you send the data from keyboard to the INPR through this transmitter interface. And when FGI, this flag is set, then data is moving from INPR to the accumulator. Okay, and here also when FGO is equal to 0, at that time accumulator, when this communication is completed from INPR to accumulator, then automatically FGI should be 0. And that time you can take the data. Here also when FGO is equal to 1, then you can send the data, the computer will send the data from accumulator to the output register. Okay. Until unless FGO gets reset, that is FGO is equal to 0, then only this data will move to the printer for printing. And when printing is going on, FGO is always be 0. After completion of this operation, FGO again be reset, that is 1. Okay, so default condition is FGI is equal to 0 when no communication between these two. At that time, keyboard can tag the data. When FGO is equal to 0, so output register can send the data to the output device, that is the printer. So this is all about your input output configuration. I think this is clear to you. Still, if you have any doubt, you can ask me the question. Otherwise, we'll move to the next part. So you have to remember here, this flag register, these are most important. They are controlling. Okay. So these are controlling. Why it is so? Because you people know that the input device and the processor are having the different speed. So that's why INPR is there and FGI is there. FGI is controlling. Okay. So until and unless this communication completed, you can't take the data once again. When this communication completed from these two parts, INPR to AC, then you will take the next data. So this is the way. So INPR, out R, output register, and FGO and FGI. These are most important here. These are the input output instructions. Okay. These are the input output instructions. Now you have to D7. What does it mean? IO instruction. As I mentioned you, IO instruction, input output instruction, or क्या था register instruction that we have discussed. Memory instruction we have also discussed. So IO instruction means D7 means 12, 13, 14. 12, 13, 14 pin number should be 111. So that's why it is D7. Okay. And I means the 15 number bit that also be high. Okay. That also be high. So 15 number bit also high. 14 number bit also be high. 13 number bit also be high. And the 12 number bit also be high of the instruction registers. Then only we go for input output instruction. So as a whole, so D7, I and T3, because at T3 this is actually executing, so that's why T3. So D7, I, D3, the total, okay, total must be present here. Then in short we are writing it's a P. P means you can understand D7, I and T3 means it's a IO operations, IO instructions. Okay. So D7, I, T3 means it's a IO operations. Okay. So that is in short we are writing it's a P. You can choose any other letter also. So P common to all input output instruction, because this is common to all input output instruction. Karan you people know that I should be high and D7 also be high here. Okay. So this is the case. And IRI means it is the instruction register bit position. That means instruction register bit positions means they are indicating bit in IR means 6 to 11. Okay. IR means the IRI instruction registers. So instruction register ka I, that is we are writing BI, and how many bits? IR ka jo 6, 7, 8, 9, 10, 11. So higher order 6 bits. So 0 to 11, how much bits are there? 12 bits are there. But here 6 to 11 means 6, 7, 8, 9, 10, 11. How many bits? 6 bits are there. That specifies the instruction here. Okay, so that is your IRI. How many bits? 6 bits. Starting from 6 to how much? 11. Okay, so this is the case. So whenever you are starting the operation, SC should be 0. Clear the SC. Now in INP, INP means input character. That means you are going to write something in the keyboard. You are inputting something. So in that case, this is INP. You are sending some data from the accumulator to the output or printer, maybe. In that case, it is out. So output character. SKI means skip on input flag. Okay. Skip SKO means keep on output flag. Okay. So you have to check whether flag is set or reset. Okay. If it is set means you can't take the data. That means that the communication taking place between your input register with the accumulator, or accumulator with the output register. So that's why in that time INPR or output register both are not taking any data. They are engaged. So that's why you have to skip over there. So that's why these two instruction SKI or SKO. ION, that means you are taking you are enable or not taking some interrupt. So ION, it is called interrupt enable on. When this is on, this means you can have the you have the access of interrupt. Okay, you have the option of taking interrupt. So interrupt enable pin. Okay, ION means interrupt enable on. Now IOF means in that case IEN should be high when ION instruction is activated. So interrupt enable on means IEN register should be reset. Okay, IEN register, this flag should be set. Or off means IEN register should be reset, means 0. And bit position, see here, the bit position. Listen, see carefully. How many bits are there? 6, 7, 8, 9, 10, 11. 6 bits are there. And each and every bit having the some particular operations. Okay. So input character at that time B11. Okay, B11. Okay, that means PB. So P means D7, I, D3. You are indicating that with that which bits 11 number bits. What will happen? What the operation will go on over there? When input this instruction you will use at that time. What operation taking place here? See, input. That means input character. You are going to write something through the keyboard. Listen carefully. You are writing something through the keyboard. So in that case, FGI should be 0. Until and unless you are making the FGI 0, you can't take the data from keyboard to the INPR. So that's why FGI is going 0. And okay, and after that the INPR. Okay, so INPR, the data which is having in the register, now they can send the data to the accumulator, and accumulator 0 to 7. Accumulator 0 to 7 because INPR having the 8 bits. As I mentioned you, INPR or OUTR, output register, both are having of 8 bits. Okay, so that's why you can now INPR ready and you can send the data to the accumulator. Now PB0 in the same way you are sending the data, okay, from accumulator to the output register. In that case, output character, that is OUT, that instruction you have to use. Okay. Similarly, IN is goes high when interrupt enable pin is on, or interrupt enable pin off means IN should be reset. So when IEN pin having high value, that means your computer is ready to accept some sort of interrupt. When this pin is low or this flag is low, that means this is off now. So you can't take the interrupt more. So these are the input output instruction you keep in mind. If question come, write down some name of the input output instructions. In that case, you have to write and their functions. Okay. So for interrupt, I will go move to give some idea. Okay, I will move to give some idea about interrupt. See, this is a normal operation before interrupt. Okay, it's a normal operation is going on. Somehow your current instruction is at 255. Listen carefully. Normal operation is going on. No interrupt right now. So you are at 255 locations. That means the instruction which is written in 255 location, that is executed. So what should be the content of the program counter right now? If you are executing the instruction which is written in 255 locations, then what should be the address of the program counter now? Content of the program counter? Anyone? You are at 255 memory locations. So what would be the address or the content of program counter right now? If you are executing the instructions which is written in 255 locations. So your execution position is 255, means the 255 location में जो data है, जो instruction है, that is executing. So right now, what should be the content of the program counter? Anyone? What should be the content of the program counter? Anyone? If the current position is 255, computer executing the instruction which is written in 255 locations. At that time, what should be the address of the program counter? Because 255 is in the address register. So what should be the content of the program counter? Anyone? No one can give the answer.
Sir, 256.
256 would be the content of the program counter. Okay, very good. So that means if you want to come back again, where you have to come? At 256 locations. At 255, when you are executing 255 is the instruction of the 255 locations, at that time, if interrupt occurs, that means your returning address is you will come back again at 256 locations. Am I correct?
Yes, sir.
So in that case, what will you do? Your computer will do one operation. That means the content of the program counter must be stored somewhere in the computer or the stack, memory address or the stack or some registers. Our case here we are keeping it at 0 locations where the 0 memory address. Okay. So see here at 0 locations जो यहाँ पे blank था, what happens after receiving of the interrupt? We have stored 256 where at 0 memory locations. What will you do? This is 256 location. Now what will happen? Is 0 position. So program counter का content क्या हो जाएगा? 1. You have to reset. Sorry, you have to set the content of the program counter with 1. With 1. Because you have kept the returning address at 256 and program counter content is 1 and this is now begins its operations. Okay, begins its operations. So 0 branch 1120. So where it will move? It will move to 112 20 locations. Okay, 1120 locations and it is a 0. 15 number bit में क्या है 0. That means direct in addressing. That means you will move directly to 1120 locations. Computer control will move to 1120 locations because it's a direct addressing. If it is 1, then you don't move directly 1120 location because 1120 location में जो data है वो address of the operand and that location you have to move if it is 1. That is that you have to find out the effective address over there. But here you need not to calculate the effective address because you got the data whatever written here 1120 that is the address effective address. So that's why your control will come out here 1120. Now IO program is written. So IO program is written means INPR, outer or FGI, FGO, whatever that sort of operations. That means the data communication taking place between your input device to the computer, computer to the output device. After finishing of that, it will come again 1 BUN 0. Why it is so written? Because your returning address is written over 0 locations. Okay, so that's why, and it is 1. See here, it is 1. That means it is not the direct addressing, indirect addressing. What does it mean? That means 0 location में जो data है, that is also address of the some other location. That means you have to move that locations, not 0 location. So 0 location के first आओ कहाँ है क्या है 256 है to come 256 again. Okay, so you have come back 256 location again. Then you go it's normal operation. Okay, so that's why when you have any sort of interrupt, you have to keep the returning address, go there, perform the task, come back again at its original position. So this is the case. So now we'll move for some flow chart. After that, I will end this session. Then we go for digital communication. Now, for interrupt, you are having one register, R. One flag is there, R. If R is 1, that means interrupt occur. If R is equal to 0, so no interrupt is there. So when R is equal to 0, no interrupt means normal execution. Okay, instruction cycle. जो तुम्हारा इंस्ट्रक्शन है वो एग्जीक्यूट होगा, नॉर्मल एग्जीक्यूशन होगा, इंस्ट्रक्शन साइकिल होगा, जो तुम्हारा फेचिंग ऑफ इंस्ट्रक्शन, डिकोडिंग एंड एग्जीक्यूशन, वो जो प्रोसेस है वो हो जाएगा. इसलिए इधर आ गया, देखो 0 fetch and decode the instruction, then execution of the instruction, again it will come back here and it will check. Okay, now if R is equal to 0, you have come here, fetch and decode the instruction. Now suppose there is any sort of IN, IN pin is there. If R is equal to 0, now you have to check every time IN pin. Okay, इनिशियली नहीं है तो क्या है, तुम फेच एंड डिकोड में आ गया, लेकिन अभी भी तो आ सकता है. So this is one part. Also you check this part, IN pin, whether it is 0 or 1, interrupt enable pin, if it is on or off. If it is off, so you come here, again you check R, whether it is 0 or 1. Now if IN is equal to 1, means interrupt present. Okay, interrupt enable pin is high. So now you have to check FGI pin, that flag, whether it is 0 or 1. If FGI is 0, okay, so that means you can't take the input data, isn't FGI is 0. Sorry, if FGI is 0, then FGI, you have to check FGI. If FGI is equal to 1, okay, FGI is equal to 1 means you are you want to send the data to the accumulator. Okay, so if FGI is equal to 1, then see here, you have to take some, you have to reset the R, means interrupt. Okay, you have to set R, means you have to take the interrupt, because you are you want to transmit the data. Okay, so that's why you have to take the interrupt, means you have to stop the instruction, normal instruction cycle. So that's why you set R1 and you coming here, and R1 you go to the interrupt cycle. You go to the interrupt cycle. Now if here enable input is 0, then you again come here and moving to the first position. We'll check R whether 0 or 1. But if it is enable input it's 1 and FGI is 1, then you are moving here, I told you. Now IN is 1, came here, FGI is 0, now you have to check FGO. Okay, when FGO is 0, so you are not sending the data from accumulator to the output register. So that's why you come here, no interrupt actually set, you need not to set the interrupt. So that's why you come here and moving in the first position. Now if FGO means the output flag is 1, so 1 means there is a communication between the accumulator and the output register. So that's why you have to set the flag R, and you are taking to and you are coming here and go there. If R is equal to 1, then what will you do? That means you are taking the interrupt, that means interrupt is present, interrupt cycle में आ गया तुम, क्या करोगे तुम, मैंने जो बोला था, store and return address, store return address, कहाँ, इन 0 locations, कहाँ पे हम लोग रखे थे, 0 location में रखे थे. So that's why the content of the program counter is stored where, na 0th location. So m of 0, that is 256. PC का content क्या था, 256. The 256 is stored at 0 location, m of 0. So that is done. according to the previous example. Now क्या बोला था मैंने, पीसी कंटेंट को 1 सेट करो. देखो पीसी क्या था वैल्यू, नीचे में है वो एग्जांपल. देखो पीसी इज इक्वल टू 1. सो 0 में 256, पीसी का कंटेंट 1. ओके, पीसी का कंटेंट 1. सो पीसी 1 हो गया. नाउ IN 0 R 0 means this is off, means you can't take interrupt again until and unless these are high. High means you are having interrupt, isn't it? IN is equal to 1 or R is equal to 1, then that means you are able to take interrupt. So until and unless this operation has been completed, you can't set this IN and R. So that's why it is now 0. So come here. So this is the flowchart for the interrupt cycle. Okay. So this is all about today's class for CO. So you go through this interrupt and
सर
IO cycle. Okay. बोलो.
सर एक बार सर आई एन एंड आर को सर थोड़ा सा एक्सप्लेन कर दीजिए सर,
अच्छा
वो जीरो ही क्यों?
अच्छा, जब IN is 1, that means your computer is ready to take interrupt. Okay. Or R is 1. Okay. So when R is 1, this pin is 1 or this flag is 1, that means interrupt, your computer is ready to take except interrupt. That means, okay, so that's R is equal to 1, that means interrupt cycle में तुमको जाना होगा, क्योंकि R is equal to 1 means you have to take the interrupt. If you made R is equal to 0, but no, don't worry. Your computer is not taking any sort of, at that time, any sort of instruction interrupt. So when R is equal to 0, at that time you are moving interrupt cycle, this case. So that's why when this interrupt cycle is moving on, so that's why interrupt analog pin is also 0 and R is also 0. Your still not is completed.